So there is another type of question that you may get in the exam, which is going to ask you about deducing the charge on a certain ion. So how can we do this? This is what we're going to investigate here. We're going to see how we can deduce the charge on a certain ion. So for instance, if he's telling you about an element like calcium here, okay, so and he wants me to deduce the charge if calcium forms an ion. So the first question that comes to your mind is, will calcium form a positive or a negative charge? Will calcium lose? Will calcium gain? So this can be done by looking at the number of electrons in the outermost shell of an atom, and there is a rule for this. So like we said, that filled electron shells are very stable. So whenever the atom has a filled electron shells, it would look like the electronic configuration of a noble gas, and for that reason the atom will be stable. So you can see that most of the inner shells, or the inner shells in general, are filled with electrons, and the only shell that is not filled with electrons will be the outermost shell, or what we say the valence shell. So all the elements, they tend to be like noble gases. Every element wants to have what noble gases have. So what do noble gases have? They have chemical stability. What is chemical stability? A chemical stability means that all the shells are filled with electrons. So for instance, if the outer shell is the first shell, which is shell number 1, it will be filled with 2 electrons. So if an element has only one shell, if it will be stable if this shell will contain 2 electrons. So if the element has its outermost electrons in the second or the third shell, and since these shells, they are filled with 8 electrons, once an element has these shells filled with 8 electrons, then this element would be stable. And as you can see, for that reason, noble gases, they are unreactive because they have filled shells. So they don't want to lose, they don't want to gain. They are already filled, they already have this chemical stabilities. But for other elements, in order for them to achieve this chemical stabilities, they must form ions, or they must enter into a chemical bonds by forming compounds. So let's look at forming compounds. This is an example of how the noble gases would look like. They would look like this, with an outermost shell that has 8 electrons, and we have only an exception for this. We're going to talk about this exception later on. So we have a rule, which is the octet rule. And the octet rule states that atoms, they tend to gain, lose, or share electron so as to have 8 electrons in their outermost shell. So if we look at potassium here, it has only 1 electron in its outermost shell. So potassium would like to lose this 1 electron. So if potassium has lost this 1 electron, the outermost shell will be this one, the inner one here, and it will have 8 electrons that would be like noble gases. Looking at nitrogen, and nitrogen has 5 electrons in its outermost. So if nitrogen gains 3 electrons, then it would have 8 electrons in the outermost. It would be stable. Looking also at oxygen, since it has 6 electrons in its outermost, if oxygen gains 2 electrons, then this outermost shell will contain 8 electrons, and oxygen will transform into a stable ion. So is there any rule? Because we have seen that some of the elements lose and some of them gain. Well, luckily there is a rule, and the rule is metals, they have less than 4 electrons in their outermost shell, so they lose these electrons to achieve stability. So magnesium here, having 2 electrons in its outermost shell, it will lose these 2 electrons to achieve stability. As for nonmetals, they have more than 4 electrons in the outermost, so they will gain electrons to achieve stability. So if we look here at sodium, and we have here sodium atom, and for sodium atom, as you can see here, we have 11 protons, 11 electrons, and the total charge is 0. Looking at the outermost shell of sodium, we will recognize that of course sodium is a metal having less than 4 electrons in the outermost. So in this case, sodium will lose this electron. So here is the configuration of an ion of sodium, and if you can see here, after losing this electron, sodium has achieved the octet rule. The outermost shell has 8 electrons. Okay, but now sodium has transformed into an ion because the number of electrons is less than the number of protons. Let's look at another example, which is the magnesium atom. So here the magnesium atom has 12 protons, 12 electrons with a total charge of 0. And to achieve stability, magnesium, because it has 2 electrons in its outermost, it's a metal, so it will lose these 2 electrons and forms a positive 2 ion. Okay, let's check this. Yes, and this is magnesium ion. For a fluorine atom, if we look at the electronic configuration, we would find that it has 7 electrons in the outermost. More than 4, this means that fluorine is a non-metal. So a non-metal gains electron to achieve the octet rule and to achieve stability. So in this case, it will gain only 1 electron to make the outermost shell contain 8 electrons. So that's a -1 charged ion. So fluorine will form fluoride ion with a -1 charge. Another example for nonmetals is sulfur, and sulfur has 6 electrons in the outermost. Then it would gain 2 electrons to become a sulfide ion with a -2 charge and 8 electrons in the outermost. So you can try pausing the video at this point and try to do the electron shells and the charge on the ion of each of these elements. Will it lose? Will it gain? How many electrons will be lost? How many electrons will be gained? And of course, the charge on the ion. And we're back, and the answers are the following. So the first one, it's a metal, loses 2 electrons. Second, loses 1 electron. A third gains 3 electrons, and the fourth and the fifth. And of course you will see here that hydrogen is not a metal, and despite this fact, hydrogen has only 1 electron in its outermost. So hydrogen is an exception for the octet rule. It loses actually 1 electron like all metals does, but actually it is a non-metal, as you all know. And there are more exceptions to the octet rules, and these exceptions are for these elements that would tend to look like helium, which is also a noble gas, but since helium has only 2 electrons which are located in the first shell, and you know for sure that the first shell is filled with only 2 electrons, so for these elements, filling their first shell with 2 electrons is enough for them to become stable and become like helium. And this is what we call a duet rule. So a duet rule will apply only to these elements, beryllium and lithium, which tend to look like the noble gas helium with 2 electrons in the first shell. And this is also another explanation for this. Do we have a rule? Are we supposed to, whenever given an element, to try to think about how many electrons in the outermost, will it lose, will it gain, and all these stuff? No, you don't have to think about this, because there is a rule, and the rule will come from the position of the element in the periodic table. So if you have an element in group 1 of the periodic table, then all these elements will have 1 electron in their outermost. They will lose this electron and they will form a +1 ion. Group 2, 2 electrons were lost, forming +2 ion, leaving the transition metals to next year. So, and for the group 13 here, group 13, okay, that's a +3 ions, and also we will leave group 14, but not for next year, it's also for this year, but later on. So we will start looking at the non-metals, and the non-metals are located in group 15, 16, and 17. So for group 15, you will notice that all the elements will have 5 electrons in their outermost, and they tend to gain 3 electrons, forming a -3 charge. For these elements in group 16, they have 6 electrons in their outermost, they gain 2 electrons, and they form -2 ions. And for group 17, 7 electrons in the outermost, then they gain only 1 electron to form a -1 ion. And of course, all noble gases are already stable, they already have a full outermost shell, they don't lose, they don't gain, and of course they have a charge of 0. Okay, so remember that whenever you go into the exam, this is the first thing that you have to do. Take the periodic table, put the charges on the periodic table, and you will know which type of ion and what the charge on each ion of the elements in the periodic table. As for the transition metals, we will discuss them later.